to attend this webinar, and thanks to Lucas for arranging and all the team at IWater for facilitating this. And the topic we're going to be discussing today is asset health and condition data driven approach to asset management within the water industry. And just to give some introductions for myself and Joe, so my name is Brian Gunnigan. I work with a company called Binnies. Some of you might have heard of Binnies before. Joe will give a bit of an overview of the company shortly, but just a bit about us. So I'm about 3 years working with Binnies. We work within the operations and maintenance asset management team, primarily working with water industry clients. My background, I've been about 3 years with Binnies, and my background prior to that was about 10 years working in the manufacturing sector, working in a range of process optimization and reliability engineering and process engineering and CI roles. Joe, I'll hand over to you now if you want to do a quick introduction.
Brilliant. Thanks, Brian. Afternoon, everyone. So yeah, as Brian said, my name's Joe Denver, principal consultant at Binnies. So it's part of the same team as Brian within the operations and maintenance excellence team. There we sit kind of under the asset management umbrella. So I'll kind of explain how that team's set up on a following slide. I've been with Binnies just over 3.5 years now. So I joined February 2022. Prior to that, I was client side in the water sector, so I've kind of always worked within the industry. So I started back as an apprentice for electrical maintenance on wastewater, then moved through various roles within the organisation at the time, and then moved over to Binnies, as I said, in February 2022. And my role within the team, so as principal consultant, is I kind of lead and deliver multiple projects for our clients. So I don't know, there may be some on the call who I've worked with across some of our projects. Additionally, then kind of line management responsibilities and kind of project leadership. But then additionally, as well as that, I head up our operational excellence offering as well. So if you think kind of lean improvements, kind of efficiency drives, waste reduction, all that sort of stuff, that kind of sits in my camp as well. So yeah, that's me, and nice to meet you all. Next slide, please, Brian. So, as we said, Brian and I both work for a company called Binnies. Some of you may have heard of us, some of you may not. As I said, we predominantly sit within kind of the water sector, but our offerings within asset management we have diversified slightly across other sectors, so manufacturing, transport, and energy, as well being some of our kind of key areas also. Binnies itself, it's got quite a rich history. So we're over 100 years old now. So you can see founded in 1909. So back then it was Binney and Son Civil Engineering, I think it was called. And yeah, kind of primarily focused there on civil engineering. Since then, we've been through numerous iterations of the name and kind of moved around a little bit. So anyone familiar with Black and Veatch? Up until a few years ago, we sat under the Black and Veatch umbrella and kind of was part of their organisation. So Binnies Black and Veatch had been involved with quite a few kind of delivery projects over previous years. More recently, so we're Black and Veatch kind of we're looking to kind of sell, so we moved over to RSK. So RSK are essentially the mothership. 200 companies now. I mean, that will most likely have grown. Like RSK as a company kind of gone quite a few acquisitions, but like I said, over 200 companies that we have access to as our network. So an RSK itself, we're one of the largest organisations. So you can see on screen there, 638 professionals. That's most likely out of date and will have grown since this was put together. So Binnies are one of the larger organisations within the group. It kind of ranges from us and a couple of others who are similar size to us, down to 1-2 man bands kind of working out of a tin shed somewhere with a real niche specialism of what they do. So like we've got organisations like ourselves down to tree surgeons, people who deal with fish passes, as kind of a couple of kind of out there examples. What that allows for us, though, as Binnies and being part of RSK is that we can access all of those different organisations as well. So should clients have requirements that we can't necessarily satisfy from kind of our skill set, it's highly likely that we can access someone within the group who can still provide that service and kind of work together with us to ensure that we're delivering quality outputs for our clients. In terms of geographical spread, you can see there with the image on the left, we kind of spread from Scotland down to South Coast, kind of main hub offices being Glasgow, Chester, Birmingham, and our head office in Redhill, so just south of London, now towards Guildford, with then kind of satellite offices dotted around the country and kind of co-locations between either RSK themselves or other RSK companies. Okay, next slide, please, Brian. So Binnies, kind of as a whole with the services, you can see they're kind of across that cycle that it's broken down into three divisions: consult, delivery, and manage. So the consultancy leg of it is kind of, if you think environmental consultancy, ecology, kind of flood and coastal risk, rivers and reservoirs, nature-based solutions. We have a team of kind of environmental consultancy professionals who can support with that. Equally, we have the delivery leg. So this is kind of your typical design and build. Binnies tends to do more of the design and then kind of joint venture for the build element with it. So we sit on a number of joint ventures and frameworks with water clients through AMP8. So you may have kind of seen our name dotted around on some of those too. And then the last bit there, the manage element of it, and that's where Brian and I sit. So within the asset management team. Asset management is itself is kind of we're split into subdivisions, if you will. So Brian and I sit within the operations and maintenance excellence team. Additionally, then we have our smart network services. So kind of anything around pipeline condition surveys. Kind of we've got kind of in-house capability to be able to go out and do that and kind of feed back to clients on the health of their infrastructure. We have digital products and services. So if you think all things digital twins and kind of digital solutions, we have kind of that's a service and kind of a business stream within Binnies Asset Management. We have kind of your typical, your kind of staple and bread and butter asset management through kind of our strategic advisory services and risk and decision support. So if you think kind of purist asset management, those guys sit in there. And then we have our field services team as well. So this is a new team which we've just set up. So this across us in O&M and Smart Networks, we have a team of individuals and professionals who can go out and support with the field work in terms of site surveys, but pipeline condition surveys and so on. So that's us as a whole in Binnies. If we just jump on to the next one. So as I mentioned, we sit within the operations and maintenance excellence team. So kind of what is that and what do we do? The main focus for us is ensuring that we get maximizing kind of value through the asset lifecycle. So kind of key aims for us as a team working with our clients is that we want to improve clients' asset health. We want to help teams understand and manage risk and put the right mitigations in place and equally control expenditure. We know kind of running these organizations isn't cheap, particularly when you're looking at the operations and maintenance kind of practices. We want to make sure that kind of we're working efficiently and we're helping control that expenditure for it. How do we do that? So the four boxes underneath, and we'll break out and kind of go into a bit more detail on some of the stuff we're going to talk around in terms of our service offerings on the coming slides. But the main things there and the things to call out, first of all, is we offer kind of maturity assessment. So it allows us to understand where our clients currently are versus against where they want to be, to put it kind of simply. So understand your current position. It allows versus where you want to be, and then that helps us draw out that improvement roadmap and kind of which feeds into the next bit around the strategy development. So we understand kind of where we want to be and where we want to be going and the activities we need to do to get there. We can then support with pulling the relevant strategies together and kind of supporting businesses develop those to ensure that we get buy-in and everyone knows what we're working to. Additionally, asset health-driven operations and maintenance, kind of the topic we're going to be speaking around today. This is all around kind of using the tools, the methodologies to ensure that we're doing the right maintenance, the right checks, the right tasks, things like FMEA, criticality, reliability center maintenance, understanding where we can apply technologies as an example, all to get a real focus and kind of drive and improve that asset health kind of metric, if you will. And then finally, asset care excellence. So I mentioned I kind of lead up our operational excellence offering. For us, we've badged it as asset care excellence. It's taking those operational excellence fundamentals and kind of methodologies and applying them into essentially asset intensive industries, kind of taking what you'd learn from your standard like kind of Lean Six Sigma kind of practices and applying them into vast organizations and kind of helping drive that lean improvement program. So that's us, that's Binnies, that's us and kind of what we do. I'm going to hand over to Brian now, who's going to talk around some of the kind of the typical challenges that we might come across when we're working in some of the with some of our clients.
Cheers, Joe. Thanks. Yeah, so just I guess this is kind of getting into some of the kind of core of the message that we're putting across today around kind of asset health within the water sector. And I guess from our experience, like working with like multiple water organisations across the UK, we see repeat issues, and I'm sure some of the kind of things that are highlighted in the slide would resonate with a lot of you. So, and you know, typical things that we see around this kind of stuck in reactive cycles, you know, organisations that are, you know, predominantly fix on fail, an ever-growing work bank of repairs that need to be done, which eats into the resources and capability to carry out planned and preventative maintenance, as well as any kind of predictive maintenance activities. This, I suppose, this scenario that a lot of companies find themselves in results in restrictions around planning and scheduling. If you're constantly in that kind of reactive kind of firefighting response mode, you know, looking ahead, forecasting, planning and scheduling events is challenging, because essentially you're trying to meet the daily demands that are coming in from your work bank of reactive work. And so we see this, you know, across nearly all companies that we work with. As well as that, you know, and kind of touching on the operational excellence piece that Joe spoke about a moment ago, repeat issues, so repeat offenders or repeat causes of failure across multiple asset classes, and a lack of a root cause mechanisms to actually kind of bottom out and fix, you know, the kind of idea fix forever as opposed to forever fixing. But we see a lot of challenges with that with all the companies we work for, and you know, struggling to get to the root cause and to kind of bottom out kind of repeat issues. The second point here on the bottom of the screen, accessing and using data. So we see across industry, organizations will have a lot of information, a lot of data available to them, whether that's through telemetry, SCADA, work order information coming from their CMMS systems, online and offline condition monitoring programs that can supply condition information. So lots of data, but the kind of puzzling bit is, what do you do with it? How do you integrate it into your systems, and how do you turn this information into kind of proactive and I suppose value add maintenance activities in the front line? And these are some of the kind of key challenges that we see across the water sector. And I'll just go on to the next slide here. Apologies for the kind of tongue-in-cheek animations here now, but I think a lot of us will kind of resonate with this in terms of like this, the kind of deep-rooted culture and kind of resistance to change. So, you know, I've come from an operations and maintenance background myself, so I've worked with a lot of people that, you know, on the tools, that love fixing things. And you know, I understand that as well. You know, there's a lot of I suppose people get a lot of job satisfaction from, you know, as the man here is displaying, putting on the cape and getting on and under pressure fixing something. But obviously that drives that kind of reactive environment, and it creates challenges for, you know, managing your maintenance and ensuring that you're managing the risk of failures. We see that with the deep-rooted cultural issues kind of coupled along with aging assets and infrastructure. So this is evident across the UK when you look at the amount of investment that has gone into the sector over the last couple of decades, and you know, when you actually get out to some of these sites and see the condition of them, and you know, it's quite evident that there's, you know, quite a significant age and asset base and infrastructure, and that kind of fuels this kind of reactive work order cycle. Unpredictable failures, difficult to plan, and essentially kind of sticking plasters being put on just to kind of maintain basic services within companies. So after all that negativity, I suppose the North Star here is that we see change coming. So this is more specific to our English and Welsh water companies. So AMP8, which kicked off at the start of this this financial year, is going to see the largest investment since privatisation. So upward of £104 billion is going to be invested over the next 5 years. And Ofwat have issued a mandate on companies to gain better understanding of asset health and condition of their asset base. And this is something that we've worked closely with Ofwat with, is defining those standards and developing asset health frameworks, which I'll touch on in the next slide. So I'll do my best to explain this. This is a project that was delivered by Binnies, but not specifically by me. But essentially, Binnies have worked closely with IWater to develop new standards around assessing the condition of their asset base. And essentially, the image that you can see is a roadmap, which will essentially deliver set standards to improve asset health visibility across the sector. And this roadmap is backed up by an independent commission by Sir John Culleaf, whose basic findings through this independent report was essentially that organisations need to take a more proactive approach to understanding asset health within the water sector. And I suppose the key differences to this roadmap to what has been in past AMPs is that there's kind of base by potential to essentially increase funding where specific asset classes need it. So, for example, like if we have a robust asset health framework with live data feeding in to give overall asset health scores, areas of concern can be identified through these models, and that can inform decision making. So whereby in the past, budgets would have been set prior to the AMP initiation, these new asset health frameworks will allow dynamic data sources to inform decision making. So an example being that, like, if you have a specific asset class for within an organization with a poor overall health score, base maintenance funding will be made available to ensure that the kind of the required maintenance is complete on those particular asset classes. And Binnies have played a key role in developing the standard method. And essentially it's going to be one standard for carrying out condition assessments for all water companies. So as this is an example of how these asset health frameworks will work, and it's essentially a combination of kind of two main inputs. One being criticality, so criticality, say, implemented at site and process level, but also equipment level, and that will allow the roll up to give overall asset health scores for your, again, site, process, and specific pieces of equipment. This is combined with your overall your asset health condition assessments. So some of these may come in the form of visual inspections, but I think the crucial thing here is how these models can evolve over time. So particularly when you get down to the bottom section here, where we see equipment criticality weighting. So examples of this and how equipment asset health can inform these models is by other dynamic data sources. So what I mean by that is, other than having a static asset health score, which is kind of set based on one assessment, these models can evolve over time and be informed by condition monitoring data. It can be informed by SCADA, telemetry, or CMMS data. So essentially, over a year-long period, you may have one asset health score attached to a particular piece of equipment. If a change in condition is detected through a condition monitoring sensor, or if a drop in performance that's picked up through telemetry, or if of failure rates coming through your CMMS systems, or a lack of completion of predictive maintenance, all these kind of data sources can feed into this model to drive out a more dynamic overall asset health score. And these models, again, essentially will kind of support long-term planning and resilience by identifying emerging risks within specific asset classes. So I'm going to hand back over to Joe, and Joe is going to discuss some of the kind of demands that we see coming from the sector and some of the kind of specific service offerings that we are helping clients with to develop these asset health frameworks.
Cool, thank you, Brian. So yeah, we said roadmap a few times already, but we've got another road on here, so apologies for keep using that analogy. So yeah, kind of this slide and the following slides are going to talk around some of a bit more in detail of what we offer as a team and as an organisation, and equally kind of these are some of the common things that we're starting to see and feel pulls from our clients and kind of some of the work that we're doing now. Some of these could be standalone activities and kind of projects in isolation, or in some instances we've kind of gone from this full process from kind of 1 through 7. Typically, we were going to go on that improvement journey, and I always cringe with the phrase journey, but everybody uses it. But these are probably some of the key steps that if you're looking to kind of get a grip on and understand asset health and improve it, typically the kind of process that we would go through. So if we jump onto the next slide. So first of all, developing your strategy. As I mentioned at the start, the ATOM asset health target operating model, that's kind of our framework that we use within Binnies. We have a maturity assessment as part of that. So these are kind of facilitated professional discussions with our clients and multiple teams within those organizations, really to get under the skin and understanding of how are you currently performing, kind of. So against a number of metrics, which you can see hopefully on the screen. I appreciate it might be a bit small, but we will essentially come in and have discussions with the relevant owners, kind of people involved in these different processes, to understand what it is you guys currently do. What that allows us to do then is kind of assess maturity. So what is it you currently do versus where do you want to be, and kind of what's our target, our North Star, and what are we working towards? What that then does is allows us to develop kind of your, I'm going to say it again, roadmap around kind of what it is we need to do in terms of improvement. So where we are, where we want to be, how are we going to get there? What are the tasks and activities we need to do there to get us up to that endpoint? The output of that then helps inform. Sorry, Brian, to get back.
Sorry.
The output of that then helps inform your strategy as well. So obviously, the maturity assessment is an activity kind of in isolation on its own, but then that feeds into then your strategy development. Again, for anything like this, there needs to be a strategy. People need to be signed up to it and understand what it is we're working towards and how we're actually going to go about doing it. And that needs that top-down approach, kind of that buy-in there from senior leadership, exec teams to understand this is what we're going to be doing. And as a business, we are all on board and going to support this. That then can filter down through the different levels, ensuring you've got clear, concise messaging and communications to like, not everybody wants to read a strategy document, do they? Let's be honest. But what needs to happen is once we've got a strategy in place, ensure that the key points for those who need that information are potentially summarized. So it could be in the form of like an infographic or something like that. Something that if you've got a maintenance strategy that your maintenance teams can easily see, understand and digest without having to go through a 50-page strategy document. But again, the kind of work that we've done to date has helped clients set those up as well. The next step there, around validating that baseline data. So we can't improve reliability, we can't improve asset health if we don't know essentially what we've got and the starting condition that it's in. I mentioned earlier on that we've got our field services team, so I've been involved with some of these projects myself and being out on site. Basically, it's validating what you've got. So is what it says on my asset register what's actually out on site? Do the two tally up? And whilst I'm on site, what's the condition of that asset, and feeding that back? So typically how this is approached is that we will take a copy of client's asset register, load it into our survey tool, start at the front end of site, and then sweep through it. That validates everything that you've got on site. It builds up your inventory, if you will, which then feeds into like the follow-on steps for this. Having that asset register, that kind of baseline information, is a critical foundation for this. Otherwise, everything else that you're going to do going forward is essentially done on false information. Excuse me. You can see there on the screen as an example, kind of this, so from previous surveys for this particular site, was we'd gone out, we'd surveyed kind of 1,000 assets across this site. 432 of them would touched at least one data point. Now, that could be nameplate data. It could be if you have different components that you need to register. It could be capacity. It could be equipment class, anything like that. But we've touched at least one of those key points on 432. That's increased nearly by 47% in terms of data accuracy. Additionally, registered 165 assets. You can't maintain something if you don't know it's there. So again, a near 20% uplift there on registered assets for that one site. When you roll that up, I think we saw for this particular project, it was around 30% kind of overall improvement in asset quality, in information quality, and around between 15 and 20% uplift in registered assets as well. So yeah, a really valuable exercise for it. Additionally, then the condition assessment, so that then feeds in. So whilst we're on site, again, it's non-intrusive inspections, so kind of using sensors. We're not using any, for this project at least, we wasn't using any kind of additional technology in terms of thermography or vibration analysis. We can do that if that's something that people would be interested in. But essentially what that gives you is that, again, that baseline understanding of, okay, this is our asset base, and this is how they are in terms of health. again, that feeds into then understanding where your risk lies. If you've got a critical asset that's been identified as in poor condition, then that's somewhere where you want to probably target some of your efforts to begin with. Okay, next slide. The next step then, as I said, once you've got your asset base right, is then understanding, okay, we know what we've got. We've got a lot of assets. Let's actually start to understand how important they are and kind of where our biggest risks sit in terms of kind of understanding our critical asset base. Now, I imagine a number of you, excuse me, on this call will have been involved with potentially with criticality assessment. So it's using that standardized framework, looking across a number of different criteria, be it health and safety, process safety, financial, environmental, permit, customer, and scoring kind of each asset within there. Now, how we've done this in the past is looking at the asset within its functional location, and that leads into the point that's on the screen of a pump isn't just a pump. So typically and historically, what may have happened is that you develop a maintenance strategy that then get a kind of an asset class maintenance strategy, say for a centrifugal pump, and that then gets applied to wherever there's a centrifugal pump. Criticality allows you then to pull those levers and kind of tweak what gets deployed. So using that scoring framework, you can look and understand, okay, we've got this centrifugal pump, it sits within our inlet, and based on that scoring kind of criteria, that's critical to us because that passes forward flow. If we lose that, we kind of lose a lot of the site. That's air critical. That's kind of one of our main assets. Equally, at the back end of site, there's another small drainage pump or whatever it may be. That's less critical. Historically, they would both got the same maintenance. Now, what that means is that you're potentially sending resource to go and do maintenance activities that aren't particularly value add, say. This allows us to tweak and kind of pull those levers to ensure that we are adding value add activities to the assets that need it. Okay, next slide, please.
Cheers, Joe. So like as a follow-on from criticality, in terms of like developing your asset class or your equipment specific maintenance approach, like we see RCM being utilized by multiple companies across the sector, and essentially the use of RCM is to support developing your asset tactics and developing your specific asset class strategies as to how you're going to maintain this equipment. Anyone that has been through an RCM project in the past will appreciate how time consuming it can be, and that's why it's important to integrate criticality with your RCM approach. One of these is FMEA or FMECA. Criticality can be done as a part of the RCM process, or it can be done prior. But ultimately, the outputs of this RCM exercise is to essentially have prescribed maintenance tasks that are linked to specific failure modes identified in the RCM process. So like understanding your equipment types, understanding what components are contained within those equipment types, and crucially how they fail and what causes them to fail. From there, then you can derive a potential or a feasible task which will mitigate the risk of that failure. Again, this, as I previously mentioned, this can be time consuming, particularly when you get to kind of site specific information. So to deliver, I suppose, feasible tasks, understanding failure risks, failure modes, failure mechanisms, but also understanding the site nuances. So if this is done at I suppose at equipment class level, it doesn't essentially capture what are the kind of site specific risks associated with a particular pump on a particular site, and that's why the input into RCM exercises is crucial. So having that engagement from your operations, having that engagement from your maintenance teams, and essentially utilizing that local knowledge and understanding to kind of drive out tasks that are kind of suitable for a particular site, and to ensure that it can serve its purpose in mitigating the risk of failure. I've added in on this section here IPSECA. So for anyone that's unfamiliar with this, IPSECA is essentially like a maintenance management system work, and it's all about work identification, planning, scheduling, executing, completion, and analysis. And we see like RCM FMEA as a crucial part of how you kind of identify the work that is to be done on particular pieces of equipment. However, I think we'll all appreciate and understand that you can have the best maintenance tasks in the world with the most prescriptive and all the tools and techniques outlined, but without an effective kind of maintenance management system, your task lists are not going to deliver any value. And that's why it's crucially important to have a system where work can be deployed effectively. It can be managed through the kind of work order life cycle, complete and analysed. And particularly when it gets to the evolution of these tasks, and we'll speak about standardization in a moment, but having a mechanism to allow your kind of task list to evolve over time, and that crucially comes through the completion and analysis phase here. So to verify essentially that the tasks that you're prescribing are being complete on time, that they're feasible to complete at site level. And the analysis piece then is to document to essentially, how effective have these tasks been? Are they increasing? Are they having impact on kind of key metrics, reliability metrics around availability and mean time between failure? And essentially, what is the kind of tangible outputs of these task lists through the RCM process? So I'm going to touch now on technology. So like what we see as an output of RCM, as an RCM exercise, it's not just, I suppose a number of outputs will be, new MSTs, new operator tasks, but also for highly critical equipment, we see recommendations around new technology and condition monitoring. And this is something that we specialize in, and we see, over the last number of years, a massive uptake in condition monitoring technology across the sector, and particularly like when you go to the supply chain and look for suppliers of this kind of technology, it can be a bit of a minefield. There's lots of suppliers and there's lots of new technology with the adoption of AI. There's lots of integrated algorithms that will do all this advanced diagnostics for you. And you'll get in our experience, a lot of salespeople that'll sell you a silver bullet that CBM is going to solve all your problems in terms of reliability. And the secret is it doesn't, unless it's integrated in the correct way. And I think one of the kind of key challenges that we see around kind of condition monitoring is you can have a very advanced system, but having the kind of central governance to ensure that, first of all, the organization is mature enough to have such a system integrated with other systems, having internal reliability, I wouldn't say experts, but people with an understanding of reliability and condition data to carry out analysis and to understand when's right to intervene and what the intervention is. And that's one of the key challenges. So when you look at a lot of these kind of condition monitoring dashboards, you'll see traffic light systems, but in my experience, sending a fitter to investigate a pump and saying that it's red on the dashboard doesn't really return any value in terms of a positive maintenance intervention. So having the internal systems to ensure that you understand what this technology is telling you, and having the maturity to be able to, within the organization, to act in the most time efficient way. I think the important thing as well is to know is that not everything needs a sensor. That the deployment of sensors or the deployment of route-based condition monitoring needs to be guided by criticality. And going back to kind of Joe's point earlier, having an up-to-date asset register to understand what equipment you have, having an up-to-date criticality model to understand the criticality of that equipment will then inform what tasks to be deployed and potentially what sensors to be used and at what stage. And as well as that, answering the questions prior to deploying this technology: what are you measuring and why? Why are you measuring it? If you detect something, what are you going to do about it and how are you going to fix it? And ensuring that is those questions are answered and documented within a strategy is crucially important for the kind of a successful condition monitoring system. Sorry, 1 second, I've frozen. Back to you, Joe.
Cool. To Brian. So yeah, just sticking on the technology element of it. So yeah, quite a bold statement. They're bringing F1 technology into the water sector. As Brian mentioned, kind of the frameworks and kind of sometimes the complications of bringing in additional kit sensors. Again, it's all the what are we bringing in, who's going to use it, how are we going to use it, what we're going to do with it, does the system support it, do we have the licenses and everything else in place, do the systems talk and play nicely together? It can be a bit of a challenge. It can kind of cause headaches in a lot of organizations and kind of result in not getting the value from what you've actually installed and paid for in some instances. What I wanted to do here, some of you may have been involved with this event earlier in the year, but just touch on kind of how are we hoping to help kind of overcome that? And so it's quite exciting. So Binnies have partnered with Williams F1, so the Formula One racing team. So we've with their engineering division of it, so Williams Advanced Engineering, they are the engineering leg of Williams F1 Racing, and the technology kind of vendor called Julia Hub. So they're a spin out from MIT in America. Um, the technology those guys use kind of and why this matters and why we're talking about it now is essentially kind of traditionally we rely on kind of data-driven models, like I said, putting a sensor on it, being able to extract that information, and to be able to do that, you need a lot of upfront data and a lot of upfront infrastructure and kit and technology being installed out on site. Sometimes we struggle, as I mentioned, there's sometimes kind of strategies aren't there, or there's kind of system constraints, or there's different equipment and systems not talking and playing nicely together. What we're doing through the F1 partnership is that we're actually able to overcome that using scientific machine learning. So it doesn't require large upfront data sets. It doesn't need additional equipment to get us to a strong kind of position in terms of predictability and kind of plotting asset health. It uses engineering information, so things like pump curves, O&M information, existing signals that most places already have on site, so things like equipment running current, levels of wet wells, flow rates of pumps, kind of the typical available signals being things like that. Those bits of information are more readily available to us. But using that and using kind of standard physics laws, it's way above kind of my knowledge base for it. But what it allows us to do is get to around 80% accuracy in terms of plotting that model and kind of understanding and predicting where the risk lies and kind of understanding the kind of journey to failure, if you will. Like, so what's our risk and kind of how far are we off kind of going past that failed state on the P2F curve. What we can do then is start to increase. So if we identify that it's a critical bit of equipment through our criticality analysis, so we understand kind of the impact of that in that asset failing, and it warrants off the back of the FMEA, the ICM study, that actually we could benefit from putting sensors on this piece of equipment. If we have that and using this technology, then that can take us from 80% up to 90 towards 100% accuracy in terms of taking more information and feeding into this model builds on that accuracy for it. The benefits of it kind of as it stands is that there's no need for installing any additional sensors or hardware. As I said, you can get to 80% accuracy thereabouts, given the information that should hopefully be already available on site. It maximizes existing data in that engineering documentation. So basically you feed that information into it and it uses those rules and kind of the logic that I spoke around to develop that kind of that health understanding. And then it reduces that dependency on costly data collection as well. So kind of if you think the additional purchase of equipment, sending people out on site to collect the information, kind of people processing that information, this does it all for you using readily available info. We've had some successes so far, so we've deployed it in a couple of areas. So Anglian Water and Southern being a couple of our customers who we've been speaking to about this as an example there. So the project, so as I mentioned earlier on, in terms of our services and digital products and services, this is kind of the baby, if you will. So Tom Ray, who heads up that department, he's been working with Southern. And in one example, we've seen kind of just greater than 90% accuracy in terms of using some of the pumping stations to actually start modeling this out. So when I say accuracy in terms of predicting failures and kind of understanding where it is on that curve. So it's starting to see some real benefit and kind of value being played back to us from that space. If that's new and you haven't heard of that and the work we're doing there and you were interested, this is a semi-sales pitch. Kind of, if you wanted to know more about that, just reach out to us and we'd happily kind of discuss further. But I'll get off my sales soapbox now and hand back to Brian.
Cheers, Joe. So standardization. And I think this will kind of resonate with a lot of us. Like, to drive consistency throughout organizations, there needs to be robust mechanisms for standardizations, and this can be in the form of standardized processes, or even down as far as clear and descriptive kind of work instructions for and some of the examples we can see on the screen there are MSTs or operator-led operational tasks. But having robust levels of kind of standardized documentation and having having processes in place to allow the evolution of these documents as well. So and I came from the manufacturing sector, and the amount of standard operating procedures that I saw hung on walls like this, that 10 years out of date, just gathering dust, and examples of like things being documented and standardized but not being kept alive. The idea behind kind of standardizations, and to kind of to give the Toyota Sensei quote here, where there's no standard, there can be no improvements. And whereas if something is documented once, that does not mean that that is standard forever. These things need to evolve over time, and there needs to be kind of feedback loops to kind of ensure, to process confirm the standards are working to deliver the process as prescribed, but also that mechanism to allow for the evolution, where if there's new technologies, new ideas, new kind of creativity around delivering a process, that these documents are not on version 1 for the rest of their lives, and they do evolve over time. I think the crucial thing about developing these standards as well, and I kind of spoke about that through the RCM process as well, is like these standards need to be developed in conjunction with site teams, where you've got, where we're, bringing about like new ways of working, or developing new kind of new processes, or new tasks within an operations or a maintenance team. The site teams are going to be the one delivering, and these tasks need to be developed alongside those people to ensure that that ownership and the buy-in and their wealth of knowledge and understanding is included in those standardizations. And finally, the kind of last stage in the roadmap is embedment, sustain, and improve. So embedment, changing ways of working for people to essentially changing the way people work are probably one of the biggest challenges that we see within organizations. And when it comes to the kind of I suppose cultural side of any change, there's always going to be that element of resistance to change. And I think what we have seen and our approach to this is like through the kind of involvement of people throughout the journey, but also like helping people understand the whats and whys and the needs for change. I think most people understand that with current I suppose current economic conditions, current organizational conditions, that organizations need to be moving forward to kind of keep up with competitors, or keep up with I suppose modern ways of working, and to embed that fully, people need to be brought on that journey with them. Sustain, recognized as probably the most important step. If we go back to our kind of 5S model, sustain, the last step, is always the kind of probably the most crucial, but also the most challenging. I know, me again from past experiences, like working in manufacturing sectors, like delivering projects, and people go back 6 months later and find the sustain has fallen over, and I've failed myself on that on numerous occasions. But again, it's one of the biggest challenges that that we see in terms of like maintaining and sustaining change within an organization, and from that as well, like I suppose having as remedies to that is adopting and documenting change management, and setting up mechanisms for measurements and feedback loops, and ensuring kind of corrective action plans are implemented. So having a robust set of KPIs and indicators to ensure that standards and quality are being maintained after the project is delivered. And finally, improve, utilizing feedback loops to ensure information and findings are acted upon. So, if a solution is delivered to mitigate an issue, or in response to a particular problem on site, that's not the forever solution. I think it's that idea that a continuous improvement is a constant thing, and employing that plan, do, check, act, cycle within your work will ensure that the improvement doesn't stop, and it evolves over time. Thank you very much, guys. Nearly bang on 45 minutes, so I think that's pretty good timing. Lucas, did you want to jump in here about this particular slide?
Yeah, I mean, we can just do a bit of kind of Q&A first, if you like, and then
Sure.
Kind of go on just as we're finishing up anyway. So yeah, no, thank you very much, Brian and Joe. I think yeah, if anyone's got any questions, please do, either raise your hand, pop them in the chat or whatever. We had one through from Adrian. I'm not too sure if maybe it kind of got answered for you as it went on there, Adrian, but I think it was basically just saying, yeah, condition and asset health are factors in likelihood components of risk. How would you see condition-based maintenance being the basis for informing asset management decisions without also taking account of the consequence component of risk with its associated value? But yeah, that might have been
Yeah, so I saw that come in, and then shortly after, Adrian came back with another response saying, like, kind of, well, hopefully it feels like it was answered for him. But yeah, Adrian, you're completely right. Kind of using CBM gives you that likelihood of failure, but you need to know the consequence and the impact, and that's where your criticality assessment and that framework comes into play. It's critical that people kind of know if that one goes down, what's going to happen with it, and kind of what's the knock-on effect for it. I think that can kind of lead multiple things, can't it, within organizations? It can be we need to get someone there relatively quickly and kind of get that asset back up the P2F curve and kind of increase the asset health through like frontline maintenance. It could be an asset replacement, a service task, whatever it may be. Or equally, it feeds into that wider asset management kind of strategy there and understanding where your risk lies and kind of your capital investment, perhaps that it helps prioritize spend from an organizational perspective as well, dependent on what it is that's actually needed to be done or invested into.
Thanks, Joe. Yeah, and yeah, a couple from me there. So I guess yeah, kind of cheeky question there. So I know obviously there is not a kind of one size fits all question, but I think from my perspective as a kind of design engineer that's speccing up plant and equipment and all that kind of stuff, there's always options for monitoring equipment, and I think from my perspective it's like, oh well, this is great. We can give the information, but maybe not realizing that actually is that processed in the correct way, or what do they do with that? So yeah, if you could pick only one asset or one area on site, what do you think would kind of benefit from that the most?
I think, yeah, and I completely resonate with what you said there, Lucas. And we see this across, like, you'll have a lot of OEMs that will sell you pumps with fixed sensors. But I think the biggest challenge with that is, where is that data going and who's managing it and what is it actually going to tell you? And having that kind of, I suppose, central data source that will infer condition for you. But I guess, yeah, I suppose, where do we see the most value? It's very, very hard to say in terms of, because every organization is difficult. I mean, I guess what we see is like screw pumps is one that we see. A lot of organizations having online monitoring systems on, as well as other forms of kind of critical pumping like centrifugal pumping. But yeah, I guess every organization is different, and every organization is going to have their different kind of way of calculating risk, likelihood, and criticality.
Yeah, just to build on that, I think, like I said, the criticality element plays a massive part in this, doesn't it? Like, what someone could deem as low criticality on one site could actually have a much higher impact on another site, so could warrant having like CBM installed for it and monitoring equipment there. Brian touched on the screw pumps from a wastewater perspective. Sometimes they're not easy to repair, to take out, kind of big bits of kit, big costs associated to it. There's value there in getting ahead of that failure and preventing that. Equally, from a wastewater, my background's always been wastewater, but things like your inlet screens, they're your first line of defense. If they're down or kind of they're passing or whatever that might be, that's impacting everything downstream of there. So I think from a criticality standpoint, inlets should be up there, and kind of they should be getting a lot of care and attention, because that protects everything else that's going to be coming downstream for it there.
Yeah, thanks, Joe. Thanks, Brian. Another one coming through. So based on some of the points you've mentioned in this presentation, what are the most critical success factors when transitioning from reactive maintenance to a condition-based asset health framework? And how can smaller utilities overcome resource constraints during this shift?
Okay, good question. So let's break that down. So what are the most critical success factors when transitioning from reactive to kind of proactive CBM-based framework? I think some of the points we touched on in there. So first of all, ensuring that everybody knows kind of what it is we're working towards, why we're doing it, how we're going to do it. Communication is key on this. people need to know kind of what's changing, why it's changing, how does it impact them, and what part do they play in it. I think lots of times change initiatives sometimes fall over through lack of communications, and then you find yourself back stuck in that state. Things like prioritizing kind of effort. So we mentioned the people thriving, I say thriving, like people getting more value out of fixing stuff that's broken. Anything like this is a cultural shift. So you can put all the right tools, all the right systems in place, but it's the culture there that helps drive that. If people aren't switched onto it and don't want to change, then there's going to be resistance to it. So kind of your people element is a massive thing that needs to be focused and a lot of care and attention put into with this. Additionally, then not just going carte blanche and throwing everything, all the technologies under the sun against everything. Prioritize what it is you're doing, understand where your key risks lie, understand what needs to be put in place to help mitigate that risk. And as I said, then communicate and standardize. Standards, make sure everybody are working to the same way. How I interpret a task coming through a CMMS could be different to how Brian interprets it. So you might get two different kind of approaches or outputs to it. Put those standards in place, ensure everyone's working in the same way towards that same goal, and hopefully then that helps drive your success for it.
Lovely, thank you. Another one coming through, absolutely not cheeky, not at all. So yes, this approach is focused on the condition and health of manufactured capital built assets. The sector is moving rapidly to implementing natural capital, nature-based interventions to manage service risks because of the wider range of value they bring. How would you see a condition-based approach being widened out to natural capital types of asset?
That is a very good question, Adrian. So, excuse me, kind of I'll my hand up and be honest, in terms of that kind of nature-based solution element of it, I've had little involvement with. Kind of a lot of the stuff that we focus on is kind of your manufactured kind of via your as-built assets, kind of your concrete structures, your rotating equipment. I think for stuff like that, that's where, as I said, within Binnies, we'd probably look to defer to some of our wider kind of teams. So when I mentioned earlier on around kind of the nature-based teams, like they will be able to inform into that. I think how would a condition-based approach being widened out to those types of assets? Again, it depends what would you be needing to measure on those, and how could that then help influence something for it? So is it as simple as it's operator intervention, kind of going out and doing visual inspections on those, and there's a framework set up to understand what that condition scoring is for it? I don't know. I appreciate I'm probably rambling and kind of giving a very woolly answer there. But yeah, it feels like an opportunity, definitely. So yeah, cheers, Adrian.
Yeah. And I just kind of my take on that as well. Like I could be wrong here again. I don't know much about kind of nature capital side of things, but potentially a hard thing to measure. Like would it mostly be qualitative as opposed to something linear that you can measure? Again, I don't know much about that side of things, but I would imagine like that would come from it, like is that something that would come from sensors, or is that something that would come from more qualitative survey information? But again, not 100% sure. Good question though.
Thank you. Yeah, another one in from James there. I won't read that. I mean, I'm assuming you guys can see the chat anyway, if that's all good.
Yeah, I mean, I'm just reading through that. I don't know if it's a question or a statement, James, but I think definitely it does. So criticality as a whole, kind of, I'm just scanning through the points. So danger of being exposed to people's opinion rather than data-led. Agreed. I think criticality again. I spent months locked in a room at previous employers, kind of supporting with criticality assessments, and it has to be a collaborative approach from it, and it can't be one person's opinion. You need subject matter experts in there kind of talking around and who have that understanding of the asset type, but then the process people who understand the impact for it. Typically, from an opinion perspective, yes, agreed. Kind of if we're trying to centralize something and say this asset type within this functional location, within this process is B critical, or well, no, let's flip it the other way around. If you go kind of C, D critical, lower down on that criticality scale, but then that particular site or that site manager then comes back and says, no, on my site it's different, providing then that kind of it's valid and on that site it is more important, then yeah, that dynamic element can come into it then and say, okay, as a whole, we see as a business, this is kind of the criticality, but for these specific reasons on these sites, we agree that criticality can be bumped up for it. I think the point around kind of IT, kind of operational technology as well, and kind of the using that data, that should feed into it as well.
Good stuff. Thank you very much. I think, yeah, don't see any more questions kind of coming through. Obviously, give it a couple more kind of seconds or whatever, and then can wrap up there. I guess just before we do so, just kind of plugging upcoming events for the Scottish area. So yeah, we've got a webinar in there and a couple in-person events if you're located nearby. I think if we don't get any more questions through, we'll call it there. So yeah, thank you very much, Joe and Brian. Thank you very much for joining everyone. Yeah, hopefully see you again in the future. Thank you.
Cheers, everybody.
Thanks, guys. Cheers.